GCSE Physics boosters, reflecting waves. This video is about reflection. It's actually about a few other things as well, but including reflection. And that isn't me on the title page there. Okay, now, reflection is one of the things that might happen when a wave comes to a boundary. So you have one medium, for example, air, and then you have another medium, for example, water. And if a wave is traveling in air and it comes to water, then various things might happen. Three things might happen. One of them might be that it reflects. I'll put some other examples of boundaries. There's air and a shiny metal, such as, I don't know, a mirror. Okay. We have on the left, that's somebody's kneecap. I believe that's an MRI scan. We have the ultrasound. There's a lot of reflection going on there. And we have the X-ray, the chest X-ray. Not so much reflection, but a lot of absorption going on there. So these are the three things that might happen. If a wave comes from one medium to another medium, it might be absorbed, it might be reflected, or it might be transmitted. Transmitted means it goes through. For example, light goes through glass. It is transmitted. We say it is transmitted. So absorbed, reflected, or transmitted. Now, what will happen will obviously depend on the type of wave. It'll depend on the media, as in the two mediums, the media involved. It'll also, and we'll see later in another video, that it will depend on the angle. When we do refraction, where the light changes direction. So what happens will depend on the angle that it approaches as well. Total internal reflection we're going to do later. And very often it isn't just one of those three, but it's a combination of them. Very often more than one of the above is involved. Some of the wave is transmitted, some of it is absorbed, some of it is reflected. So it's not just one of them. When a wave is absorbed, then what happens is that the energy of the wave will increase the internal energy of the medium, and it will warm up a little bit. Here are some examples of the kind of things I've been talking about. Black cars get very hot on sunny days. Don't leave your don't leave your dog in a black car unless you want a hot dog. Basically, the black surface will absorb heat energy from the sun. So it will absorb infrared radiation from the sun. It'll get very warm. Villas in hot countries are usually white because that will reflect heat energy from the sun. Radios work indoors, but the reception is better in the garden. Now, why? Because most of the radio waves will get through the walls of your house, but some of it will be absorbed, so you'll get more of a signal in the garden. Bottom left, one reason that satellites use microwaves is because radio waves can't do what? And the answer is they can't travel through the Earth's atmosphere. Okay, radio waves from Earth are actually reflected off the Earth's atmosphere, off a layer called the ionosphere. But microwaves are transmitted. They can get through the Earth's atmosphere. If we have a look at Cyril the seagull, now light from the sun is reflecting off the bird. I mean, that's why we can see it. And then some of this reflected light is reflecting off the surface of the water. Some of it will be going into the water, but some of it is reflecting, which is what we can see. The X-ray I've already mentioned. X-rays are transmitted. They go through soft tissue like muscle and skin, but they are absorbed by bone. So you blast the person with X-rays, you have photographic film or some kind of electronic detector these days behind, and some of the X-rays get through and some of the X-rays are absorbed. Here is an experiment that hopefully you will have done, or you will do, and you have a ray box producing a ray of light. This is our very first ray diagram. We're going to do loads of these when we talk about lenses. So a very simple ray diagram, and you can see that the ray of light hits the mirror and it bounces off, it reflects. Now that's the symbol for a mirror, this cross-hatching. The dotted line is called the normal. The word normal just means right angles. It means perpendicular. So that dotted line is perpendicular to the mirror. And then if you look at the two angles I and R, I is called the angle of incidence and R is the angle of reflection. And when a ray of light reflects off a shiny surface like a mirror, the angle of incidence is equal to the angle of reflection. And the photograph there shows how you would actually do the experiment, and you would need a protractor as well. And you do a range of different angles to prove that it applies to small and big angles. Remember that the angles are in between the normal and the ray. Okay, both angles are measured between the ray and the normal.